we did this one, we did this one, we did this, we did this. Let's go ahead. We did do this problem too. Now, the conversions of molarity to moles is it gets easier if you can understand the concept of small m and small v. So here is another problem. Let's try to solve it for this one. How many grams of potassium chloride are needed to prepare 125 ml of a 0.72 molar solution? So what is the question giving us? The information. It's giving us capital M, and it's giving us volume, but again notice it's not in liters, so that has to be converted, and this will be, of course, I'm going to quickly do it over here. It will be 0.125 liters because again 125 mLs, well, just go ahead and write it down for someone who may be having a little trouble. So we did that to solve to come up with this. So what are we getting is we need to find out the grams of moles. We can't get the grams of moles unless we look at the equation. We see, okay, this equation is the same, it only calculates small m. So in this equation you will first plug in the values to calculate the small m, and once you have small m, now my plan is to convert my moles to grams. So how would you do that? Again, you take the moles of a substance divided by the grams over the x moles of that, just the reverse of what we actually did in the previous problems. And using that, you can then determine how many grams of a substance is needed. Okay. So let's go back. Trying to see, yeah, there it is. Okay, so we have 2.5 grams of I think this is a different problem. That's what I'm trying to. Now in this problem over here, we can see that how many grams of aluminum chloride are needed to prepare 125 ml of a 0.15 solution. This is the one in which you will first have to solve for small m, which is going to be, small m is going to be mass over volume. Why? Because capital M is small m over small v. So we'll have to get rid to bring it over here. So small m is going to be capital M times V. Now I've done this part many times over this little section. If you're still having trouble, come see me or check with the MATLAB, and somebody can show you in the MATLAB what we're talking about. So now we have 125 ml that has to be converted to liters to this part, and you can plug in this part directly over here, and then you can isolate for moles. Once you get the moles, keep in mind then you will take your x moles, start with your x moles over here, times 1 mole of aluminum chloride is how many? So 1 mole of aluminum chloride is going to be 27 grams of aluminum. 35 times 3, if you did in the total, that would be your y grams of aluminum. So you will put in this value over here, which is y grams, and then cancel these. Actually, I need to reverse that. I just realized that I got carried away with a little bit. We have 1 mole over here, so this has to be 1 mole, and we have to have grams on the top over here now. Keep in mind why, because in dimension analysis both of these units do cancel out to then convert your moles to grams. So I want you to solve this, and then we will go back and look at it. So after solving it, you should have gotten the value of 2.5 grams of aluminum chloride. Again, this is what we started off. We converted that. We have converted 0.15 moles to the grams, and then taken in the liters. So now in this equation versus the one that we just did, it's the same thing. I want you to just notice that what are we doing over here is we're converting. Our equation was let's go back. small m over v, and we had to calculate for small m, which was m over v. So m does not even have to change. We just had to find out how much is the mass, and then once we find out how much is the mass of how many moles we get, we just divide that by the capital M, which is this one, and this part is going to give us small m. So coming back, I should have solved it over here like this for you. Maybe that would have helped. So we're trying to find small m, which is mass times. No, actually, we're trying to we're trying to get the grams for it. So that's once we get that, then this is actually one step. So once they found the small m, they just went ahead and did the solving for the grams to give us the total grams of aluminum chloride. Now in this equation, again using the same concept of capital M over small m over V, we will now show you how to isolate for volume. So how many milliliters of 2.2 molar nitric acid contain 24 grams of nitric acid. In this equation we're trying to isolate for V, and V would be small m over capital M. Again, 24 grams of nitric acid has to be converted to the moles, and 2 moles of nitric acid is already given to us. So this is 2 moles, and if I convert 24 grams of nitric acid, 24 grams of nitric acid would then give me 1 mole, and nitric acid would be 1 plus 14 plus 16 times 3. 16 times 3 is 48. Then we have 40 plus 1, so this gives us a total of 63 grams if I did my math correctly. So that would be you would solve it over here and you would get your moles, and then you plug in the moles to this equation, and this will give you the correct volume that is needed for this problem. So I'm going to go ahead and let you solve it take a little minute and see if you're getting the same value. I'm also going to go ahead and solve this equation using my calculators and to see if we come with the same problem. So coming back, I ended up solving for and I came up with 0.38 moles. So you take 0.38 moles and you divide that. Let's go back. We're trying to find V, which is going to be small m times capital M, because m equals small m over V. So V would be, actually it's going to be small m divided by, okay, let's go back over here, capital M. So you do that and you come up with 0.38 moles. Divide that by the 2 molar, and you should then get, let's see, you should get 0.19, and that is 0.19 is your ml. Notice we have to find actually no, this is in liters, because the volume that you get from this equation is in liters. So first we actually have, let's get rid of it, we're actually getting this problem solved for liters, and now we have to convert that into milliliters, so that's why you're coming up with 190 ml. So this is again all the steps that you would require to solve this sort of a problem. So here is the solved problem again for you. So I've done a couple of examples. I know for some of them I had my calculator out and I was going back and forth writing it. It's important that you take the steps and you learn how to do each one of them. My recommendation to you is for any equation that you have, learn to isolate for one of these factors. Learn to use this formula, because this is the easiest way you can do on any of the word problems. Once you know what the word problem states, just isolate it for the factor that is required. Now in this section we will start with a new concept, which is dilution. Dilution